Hello guys, very good evening. Welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all the computer exams. So today I am going to teach you about the IP version 4 addresses and the protocol of internet things, and also we are going to discuss some problems and practice problems on the IP version 4. So join quickly and mark your presence. So I hope every one of you are able to hear my voice. Am I audible? So please confirm me once. Is my audio, video, everything is clear? I once again welcome you all to this session on computer networks. So join quickly and mark your presence. I hope I am audible and visible to every one of you. So this session is especially to practice some questions on IP version 4 addresses. It is useful for NIELIT 2023 and also GATE aspirants you can watch. Okay. So if you have faced any problem in the voice or in video, you can just let me know. Yes. I hope all of you are doing good. Yes. Is my audio, video, everything is clear? Just confirm me once. Okay, fine. So now let me start the session. Before I start the session, so let me introduce myself. Myself Muralikrishna Sir, and I am having 21 plus years of teaching experience, both in the GATE and also I worked in different engineering colleges. And these are some of my credentials. Just have a look. I have mentored more than 50,000 students across the country in different core areas of computer science. Those are theory of computation, operating systems, computer organization, computer networks, digital logic, and ICT, information and communication technology. So this is about my brief profile. Yes, if you have any doubts related to IP version 4 addresses and IP version 4 protocol, you can just ask me in this today's class. And before I begin the session, you can just do like the session if you are really liking it, and also do subscribe the channel if you are not yet subscribed it, and just press the bell button for getting the notifications related to these classes. And we are providing different courses here in the YouTube channel in computer science. We are offering a fundamental series for 2024, and also we are offering a NIELIT course and also practice sessions for NIELIT, and we are offering different general courses, general sessions, motivational sessions, and post-gate guidance. Okay, so these are all facilities we are providing. So please do subscribe the YouTube channel. Okay, I hope every one of you are fine and preparing well for the NIELIT 2023. I wish you all the best. So let us move forward. So before that, so let me introduce some of the slides here for you which are useful. So we are conducting a free GATE workshop. This workshop is related to detailed strategy to secure All India under 100 in the GATE 2024 by our expert faculty Joshit Singh sir. He is having 5+ years of experience and he is having MTech from IIT Roorkee. And this workshop is on 21st May. Please remember that is on coming Sunday. So day after tomorrow at 12:30 p.m. exactly. So please register for this workshop and also please share with your friends. Okay. And these are our toppers. We got more toppers in 2023 GATE, and congratulate all these toppers. Big congratulations to especially these 3 people. And we got more than 62 students under 50 rank and 13 under 10 and 107 under 100. And some more students, many of the students are qualified who are taken coaching at BYJU'S Exam Prep in computer science and other branches. And I wish you all the best for all the 2024 GATE aspirants and also for NIELIT 2023 aspirants. Okay. So you can just say hi or hello. I think I am audible and visible to every one of you. So you can just let me know if you have any doubt. And even after the class is finished, in the comment box, you can share your thoughts. And if you have any doubts, some homework problems also I'll give you so that we can discuss those problems in the comment box after the class is finished. Okay. So shall I go ahead? Yes. Okay, fine. Now coming to the first question. Practice on IP version 4. I think most of you might be knowing what is IP protocol. IP is Internet Protocol and IP version 4 is a 32-bit IP address. An IP version 4 datagram has a total length field value of 4020 bytes and HLEN means header length field value of 0101. and MTU means maximum transmission unit, is of 1420 bytes in a network. And what is the fragmentation offset value for the last fragment? Fragmentation offset value for the last fragment you have to find out here. Okay, and datagram total length field value 4020 means it is including the IP version header. So it means that, hello Vijay Prakash. Yes, thank you for your response. Hi Vijay Prasad. So please share this information with your friends in the Telegram group and also in the other groups, WhatsApp groups, etc. How are you, Vijay? I hope your preparation is good. Now, in this actually, the payload value we can have 4000 and header value 20 bytes. This payload value is nothing but the content message attached to the header. It also contains the headers from the previous layers, obviously. Okay. Now, in this, we have to find out the fragmentation offset value for the last fragment. Okay. So, how we can divide this? Generally, header length field value, it is in the form of words. What is the word size in the IP version 4 header? Can anybody tell me what is the word size? 0101 is the binary value given. It means that in the decimal, it is 5 words. Because in the IP version 4 header, we are supposed to have the word size as in the form of bytes. So that is one word is equal to 32 bits. Okay. So in IP version 4 header, each word size is 32 bits, means 4 bytes. So that means there are 5 words, and what is one word size? 32 bits means 4 bytes. So this is equal to, in the form of bytes, it's a 5 into 4 bytes. It is nothing but 20 bytes. 20 bytes is the size of the header. Okay, and 1420. So without giving the direct header size, through header length value we could find out. So from that we could say 4000 is a payload and 20 is a header in the original datagram. So when it is passed through different networks, so just like different networks are having different MTUs, maximum transmission units. So they cannot pass the bigger datagrams. So it is supposed to, router is supposed to divide the bigger datagram into small chunks. So those are called fragments. Every fragment is supposed to have again payload and header. We are supposed to add the header for every fragment. So let's see this. So 1420 is the MTU. So what do you mean by 1420? 1420 is the total value we can transfer including the header. So that means in the fragment 1, in the first fragment, we can transfer 1400 bytes of payload and 20 bytes of header. In the second fragment also, we can have 1400 bytes of payload and 20 bytes header. So what is the total original datagram size? 4000 bytes plus 20 bytes. So we are dividing this payload actually. Okay, hope you are understanding. If you have any doubt, please ask me. And the last fragment, fragment 3. How can you say it is the last fragment? 1400 plus 1400. How much data is covered? 2800. Still, how much is left over? 1200. So this 1200 bytes of payload should be attached with 20 bytes. Whatever is left over, for that we have to attach the header. So every fragment is supposed to have fragmentation offset, which is telling the relative position of the each fragment in the original datagram. Relative position. Now let us see. So fragmentation offset for the first fragment will be 0. Even fragmentation offset for original datagram, undivided datagram also it is 0. When it is divided, first fragment it will be 0. Second fragment is number of bytes carried in the first fragment. It's a 1400 divided by 8. That is a formula. So 8 ones are 8, 8 sevens it's a 56, 8 fives. Is it clear? 8 ones are 8. So 60 is there. 8 sevens 56 and 8 fives are 40. So 175. 175 is a fragmentation offset for the second fragment. And the third fragment, sum of the data carried in all the previous fragments divided by 8. So 1400 plus 1400 divided by 8. So this is nothing but 2800 divided by 8. Are you following? It is nothing but how much it is? 350. Hope you are following. So 350 is a fragmentation offset for the last fragment. And what about the MF bit? MF bit for the first fragment will be 1, second fragment is 1, last fragment is 0. MF indicates or M bit indicates whether the fragments are there or not. So last fragment 0 means there were no more fragments further. That is the meaning. Okay. I hope you are able to understand and you are able to hear my voice. Everything is clear. And the only thing is you are not asking the doubts. If you get any doubt, please ask me. Don't hesitate to ask your doubts. So shall I move forward to the next? Do you understand how I am going to divide? It is based on the MTU. What is the need of MTU? Because when the datagram is traveled through different networks, all the networks may not be having the same capacity. For example, if a bigger vehicle is going, okay, a bigger vehicle cannot travel in a small road, right? It requires bigger road. Similarly, a bigger packet cannot be passed through a smaller networks whose capacity is less. They can't process. That's the reason there is a need for fragmentation. Okay. So that is a requirement of fragmentation, right? I hope you understood. Is it so? Please let me know. Okay, fine. Now, so this is what is the answer for this? So 350 is the fragmentation offset value for the last fragment. Option A is the right option. You also can type your options here after solving the problem. So shall I go ahead for the next problem? Yes, confirm me once. So this type of problems asked in the previous NIELIT papers. Okay, some of the gate problems directly given without changing the values also. So please go through all the previous gate years papers, especially 1 marks and some of the 2 marks questions. If you see the previous year papers, you will understand. Already in the paid course, I have discussed all the problems related to previous years. Okay. Now coming to the next question, question number 2. In an IPv4 header, which of the following fields is/r not necessarily be updated? That means it is same as that of the original datagram. Whatever is the content of the header in the original datagram, same content is for header of the fragment also. So what content is same? As and when the fragmentation is done while it is passing through different networks. So that's the question. Can anybody answer this? Option A, identification number. Option B, total length value. Option C, header length value. And option D, both A and C. Please answer this question. In an IPv4 protocol header, which of the following fields or field, one or more, so is not necessarily be updated? That means it is the same as original datagram header. So there are different fields in the IPv4 header, like you may have a version field, okay, you may have a header length field, okay, you may have a type of service field, okay, type of service field, you may have a total length field, okay, you may have a total length field, and also you may have a identification value, ID value, you may have a fragmentation offset and DF, MF bits and source IP address, destination IP address, protocol, TTL, so many fields are there. Yes, only one answer I got. Yes, Vikas Kumar is saying option A. Option A, not only option A, there is another value also. Even header, if you see this previous example, whatever is the header size of original datagram, for all the fragments, I am adding the same header because header size will not change. It is as it is. So, as per the header size means header length value remains same as original datagram. ID also will be same. So, it means that, for example, you take this example. ID value means unique identification of this datagram. Let us suppose randomly I have assigned ID value is a 16-bit value actually. So if you randomly assign ID value for this datagram as something like some 2314, let us suppose 2314 is ID. So for the fragment 1 also, all the fragments of original datagram will be having the same ID. 2314 is ID of F1, 2314 is ID of F2. Because in an IPv4, different fragments may travel in different routes, and all the routes when they reach to the same destination, and we need to combine them and we need to arrange them in a proper order. Different fragments may go in different timings. So just to combine all of them, we have to pick the same ID. So all fragments with same ID will be collected first. Using the offset value, we can arrange them in a proper sequence. I hope you understood. Okay. So that's the reason ID value is also same. Total length value will be different. So what is the total length value here? In the original datagram 4020. But here the total length is 1420. It is a 1420. It is a 1220. There is a difference in the total length field value. But header length remains same. That's why total length field value may be different, but identification value and header length value remain same. So option D is the right option, both A and C. Okay, na? I hope you understood this. Got the point? Yes, Vikas Kumar, good. And others also please respond. Okay. And meanwhile, you can do subscribe the channel if you have not yet done it. And please share with your friends. I will tell you the advantages. We are providing the free content for GATE and also for NIELIT and other competitive exams. And we are providing some of the motivational sessions and post-GATE guidance and what are the tricks for preparing the subjects, all those things we are telling. So try to make use of this and do subscribe and press the bell button for getting notifications. Okay, shall I go ahead? Yes. Okay, thank you. Now let's move to the next question. Question number 3. Which of the following statements is true about IP protocol? Can anybody type this answer? Just key. Checksum field present in the IPv4 header is computed by taking payload of the datagram as input. We need a true statement. Okay. And TTL field means time to live in the IP packet header is introduced with an eye towards optimizing the throughput of internet. And option C, an IP packet with the flag DF. DF means don't fragment. Set to 1 can be forwarded through any type of physical networks. And option D, an IP packet with the same source and destination IP addresses can take different routes. What is the right answer? At least I want at least 1 or 2 people to respond here in the chat. So we need a true statement. You know that the checksum field value present in the IPv4 header for what it is computed and what is input. Yes, Vikas Kumar is saying D. Exactly, Vikas, you are right. Option D is the right option. Checksum field value actually by taking header as input we compute, not the payload. Payload we compute for the frames, not for the packet. Okay. So that's why in IPv4 we can say that header checksum, that field itself is the header checksum. Header checksum how many bits? 16 bits. Header checksum value it is of 16 bits. Why this is required? If there is any error in the header, the receiver will recompute it and understands if there is any error in the header. Okay. So that's why this field is not correct, because we take header input content as a input for estimating the checksum. And the TTL field in the IP packet header is introduced with an eye towards optimizing the throughput of internet. No, actually TTL field is introduced time to live. For example, if I said time is some 5 hops, within 5 hops, if packet is not reached to the destination, it will be discarded. What is the reason? If we don't discard unnecessarily, there is a chance the packet may be looping among the routers without reaching to the destination. To avoid that looping of packets indefinitely in the among the routers, we do this. And an IP packet with a flag DF. DF means don't fragment. If any packet is having DF value 1 means we are not supposed to divide the datagram into fragments. But how that datagram will go to multiple networks, because different networks may have different MTUs. Okay, if the MTU is less, bigger size we can't forward. We forward only by fragmenting it. So that means sometimes if DF is 1 and we can't forward, means it can be discarded sometimes. So that is what an IP packet with the flag DF1 can be forwarded through any type of physical network is not possible, because some physical networks may be having less MTU. An IP packet with same source and same destination address can take different routes. This is exactly true, because IP network is a connectionless network. Even if same source address, same destination address, it is forwarded to router and router to router based on the present routing tables availability and routes available, it may come back to the same destination. It is quite possible. in the connectionless internet protocol. Now coming to the fourth problem, an IP version 4 datagram is having 4-bit header length field value of 1100. 1100 is the header length value. Total length field of 400. Total length field of 400. It is a decimal value. If the fragmentation offset is 100, fragmentation offset value is 100. What is the last byte ID of this datagram fragment? So I am expecting answer from every one of you. Please answer this question. It is very simple. In an IP version 4 datagram, which is having 4-bit header length field, whose value is 1100. So 1100 is nothing but it is a 12 words, because header length is in the form of words only. So 12 words is nothing but how many bytes? 12 words is equal to, one word is 32 bits, right? So 12 into 4 bytes, 32 bits is 4 bytes. So 48 bytes is the header size. Okay, na? And the total length is 400 bytes. If the total length is 400 bytes, what is the payload? Because the numbering of bytes is given only for the payload. Okay, na? Got my point? Numbering is given only for the payload. So how can we give the numbering? Just you can tell me now. Okay, that's great. Okay, so payload is equal to here. Payload is equal to total length field value minus header length. So 400 minus 48. So this is nothing but 352 bytes. So 352 bytes is the payload. Agreed? Okay. Now we have to give numbering. Actually, fragmentation offset value is 100. It means that first byte ID in this fragment, first byte ID is equal to fragmentation offset value into 8. It means that 800 bytes of data are carried in the previous fragments. Maybe from 0 to 799 already byte IDs are mentioned in the payload field of previous fragments. Present fragment is started at 800. So where it will end, present fragment depends on the number of bytes. So we have to calculate the bytes from 800. So 800 is the first byte, 801 is the second byte, 802 is the third byte. Like that, how many bytes you have to cover in this fragment? 352. So if you go up to 1151, so total number of bytes from 800 to 1151 is 352 bytes. Total number of bytes from 800 to 1151 is 352. So 1151 is the last byte ID. Option B is the right option. Hope it is clear. Okay, now shall I go for the next? Please confirm me once. Everybody, please. Okay, fine. Thank you. Vikas Kumar. Okay. Now let's move on to the next. I think this question you can answer. Fifth question. An IP version 4 datagram header has a total length field value of 0 cross 0034. Actually, it is not directly given in decimal. It is given in binary coded hexa. Actually, the total length field value is 16 bits, no? So these are binary coded hexa. So 0034, 0 cross is the hexa code. 0000, 0000, 3 means 0011, 4 means 0100. This is the 16-bit value actually. We can convert into decimal this hexa code, and header length field value 1010. HLEN means header length field value always it is in the form of words. How much it is? 1010. What is 1010? It is nothing but 10 words. Can you answer this? 10 words is nothing but 10 into 4 bytes. So 40 bytes. So 40 bytes is the size of the header. And how many bytes of the payload is present in the datagram? Very simple question. If you wanted to know the payload size is equal to header total length minus header length. Payload size is equal to total length minus header length. Both are you can take in bytes. Payload is equal to total length minus header length. So what is the total length field value here? Total length is 0034. So you can convert into decimal. 0 cross 0034 means it is a 3 into 16 power 1 plus 4 into 16 power 0. Am I right? So this is nothing but 48 plus 4. It is a 52. 52 bytes is the total length. So 52 bytes minus 40 bytes is the header size, right? 52 bytes minus 40 bytes. So what is the value finally? 12 bytes. Only payload size is 12 bytes. Just it's a hypothetical example. Practically it may not be possible because even we are having transport layer header and all other things also. Okay. So option A is the right option. Shall I go for the next? Is everybody okay with this? And if you have any doubt, please ask me. Next question, question number 6. A host sends datagram of size 10,000 bytes, excluding the header of size 20 bytes. That means this 10,000 bytes is not including header. So 10,000 bytes is only the payload plus 20 bytes is the header. It is passed through a network whose MTU is 1500. So MTU 1500 means including header. By default, including header, MTU 1500 bytes. And which of the following statements is slash or false? Which of the following statements is slash or false? So first of all, you have to see how many fragments are there. Then only false or true statements we can evaluate based on the options given. The last fragment will have total length field value of 1024. So without knowing how many fragments, what is the size of last fragment, we can't understand. Total fragments of the datagram is 6. The offset value of the second fragment is 185. Option D, both A and B are false. So let us see this. Okay. Is it okay for you? And if you get any doubt after the class, you can go through this comment box and type your question in the comment box also. I will help you. And before we proceed, you just share this information with your friends, and also you can do subscribe it if you are not yet done so far. Okay. Okay. So 10,000 bytes. Let's see how it is divided. So 10,000 bytes of payload we have to divide into multiple fragments. So first fragment, as MTU is 1500 bytes, we can have 1480 plus 20, and we are supposed to have this, the size of the fragment except the last fragment, remaining all fragments, the size of the payload should be multiple of 8. So 1480 is a multiple of 8, no problem. And fragment 2 also 1480 plus 20. Fragment 3 also 1480. Like that we take 6 fragments. Fragment 4 is also 1480 plus 20. Fragment 5 1480 plus 20. Fragment 6 is also 1480 plus 20. So how much data is covered out of 10,000 in these fragments? 1480 into 6. 8,880 is covered. So 10,000 minus 8,880. How much is the leftover? 1120, right? It is 1120. That means last fragment, that is a fragment 7. Fragment 7 is having 1120 plus 20. So of course offset values, if you see, we have to write like this. Offset value, first fragment offset value will be 0. First fragment offset value is how much? 0. Second fragment 1480 divided by 8, it's a 185. It's a 370. Like this it will go. 1480 plus 1480 divided by 8 is 370. Again 31480s, keep on adding 185 like this. Total fragments are 7. Okay, so total fragments they mentioned is 6. It is a false. This is a false statement. Last fragment will have total length field value 1020. This is also false, because last fragment total length field value 1120 plus 20, it is nothing but 1140. So 1140 is the right answer actually. Total length field value for last fragment, he mentioned it is 1020, it's a false. Offset value for second fragment 185, that is a true statement, because second fragment is 185. So our data is sufficient here to answer this question. So both A and B is a right answer, because they asked about false statements. Okay now? So I hope everybody got a clarity on this, and keep asking your doubts in the comment box also. I'm just concluding the session for today. I hope you people have enjoyed the session. So please do share with your friends and subscribe the channel and press the bell button for getting the notifications. Okay. So still, if you have a doubts, you can make the comments in the comment box. I will continue giving you some inputs on these problems. Okay. Thank you so much. Thank you one and all. Have a good night. See you all on Monday. Again, I will be taking one more class for computer networks. Thank you so much. Bye bye.